In this lesson, I'm going to show you how to use a PDF for the Poisson distribution to calculate probabilities. If you still remember, the PDF for the Poisson distribution is probability capital X is equal to small x equal to e power minus lambda, lambda power x over x factorial. And x takes values 0, 1, 2, 3, 4 up to infinity. And lambda is a parameter of the Poisson distribution. It represents the mean. Now let's take a first example. If x follows a Poisson distribution with parameter 4.3, find probability capital X is equal to 6, probability X is equal to 0, and probability X is less than 3. Let's take one by one. So the first one is to find the probability X is equal to 6. And we know that lambda is 4.3. So we replace x, small x by 6 and lambda by 4.3 in the above PDF. So we have e power minus 4.3, 4.3 power 6 divided by 6 factorial. And the answer is 0.119 to 3 significant figures. So I repeat, we replace lambda by 4.3 and small x by 6. The second one, probability x is equal to 0. Again, we replace lambda by 4.3 and then small x by 0, the whole divided by 0 factorial. And we obtain e power minus 4.3 because 4.3 power 0 gives us 1 and 0 factorial also is 1. So probability x is equal to 0 simply becomes e power minus lambda. Here it is e power minus 4.3. So whenever we have to calculate probability x is equal to 0, we just have to calculate e power minus lambda. And the final answer is 0.0136, 3 significant figures. Third part. Probability x is less than 3. So x takes values 0, 1, and 2. And then we have to calculate each one using the PDF. So for probability x is equal to 0, we just saw that it becomes e power minus 4.3. For probability x is equal to 1, it's e power minus 4.3. 4.3 power 1 over 1 factorial. For probability x is equal to 2, it's e power minus 4.3, 4.3 square divided by 2 factorial. It is more efficient to take out a factor of e power minus 4.3. rather than calculating the individual terms here. We have e power minus 4.3, e power minus 4.3. So we just take it out. it becomes easier for calculation purposes. So when we do so, we have e power minus 4.3 into 1 plus 4.3 plus 4.3 to the square over 2 factorial, which is 2. So inside the bracket, we have 14.545, which we multiply by e power minus 4.3, we obtain 0.197. Again, to 3 significant figures. So when we have several probabilities to calculate, I repeat, it is better to take e power minus lambda common. And then we calculate inside the bracket, and then at the end we multiply by e power minus lambda, here lambda being 4.3. And for probability x is equal to 0, it's just e power minus lambda. Now suppose we had to calculate probability x greater or equal to 3 for the above Poisson distribution. That is, x takes values 3, 4, 5, 6 up to infinity. So how are we going to calculate all these probabilities? It is impossible to proceed in this way. Rather, we would have to use complement. That is, we take 1 minus probability of the remaining values. So we have to calculate probability x is equal to 3, 4, 5, 6. What remains in front? We have 0, 1, 2. So we take 1 minus probability x is equal to 0, 1, and 2. That is 1 minus probability of x less than 3. And we have already calculated it above. So we take 1 minus 0.197. So this is the way to calculate probabilities when we have greater or equal to. So we have to calculate probability x is equal to 3, 4, 5, 6 up to infinity. It is impossible to proceed in this manner. So we take 1 minus probability of the remaining values of x. That is 1 minus probability x less than 3. We have 1 minus probability x is equal to 0 plus probability x is equal to 1 plus probability x is equal to 2. So this part we have already calculated it in the third part. So we just take 1 minus 0.197 and we obtain 0.803. Now we have a second example. The number of calls to a consumer hotline is modeled by a Poisson distribution with a mean call rate of 6 per minute. Calculate the probability that in a given minute there will be 9 calls, second part 3 or fewer calls, and part C at least 1 call. So here it is clearly said that it is a Poisson distribution, because here we are looking at the number of calls per minute. So we have time interval, and we are modeling number of occurrences of an event. The event is number of calls to a consumer hotline. So per minute, the mean call rate is 6. This is the value of lambda, the mean value per minute. So we have to state the random variable we are working with. So here we say x follow a Poisson distribution with parameter 6. Or we can write x as let x be the random variable, number of calls received per minute. So next we write x follow Poisson distribution 6, and we know that x takes value 0, 1, 2, 3 up to infinity. So part A, we have to calculate probability that 9 calls are received in 1 minute. So probability capital X is equal to 9. So it's e power, we are using the PDF for the Poisson distribution. It is e power minus 6 power 9 over 9 factorial, which is 0.0688. This is part A. And part B, at least 3 or fewer calls. Probability capital X is less or equal to 3. So it's e power minus 6 power. So first of all, let's write the values taken by x. 0 less or equal to 3, which is 0, 1, 2, and 3. Because we have equal to, we have to include 3. So it's e power minus 6. For 0, it's 6 power 0 over 0 factorial. For 1, it's 6 power 1 over 1 factorial. For probability x is equal to 6 power 2 over 2 factorial. And then for probability x is equal to 3, it is e power minus 6 power 3 over 3 factorial. So to make the working more straightforward, we factorize out e power minus 6. And we obtain 1. For probability x is equal to 0, this becomes 1 plus 6 plus 6 power 2 over 2 factorial plus 6 power 3 over 3 factorial. And we obtain 0.151 to 3 significant figures. And the last part, at least one call is received. At least one call. At least one call, this means x is greater or equal to 1. Minimum one call is received. So here we have to calculate probability x is equal to 1, 2, 3, 4 up to infinity. Again, we cannot calculate it in this way. We have to use a complement. So we have 1 minus probability x is equal to 0. because we have to calculate all these probabilities. So instead we just take 1 minus probability x is equal to 0, which is 1 minus e power minus 6. Probability x is equal to 0 is just e power minus lambda. So here it is e power minus 6, and we obtain 0.998.